All right, so we're now going to move on to the second part of chapter 6, and that's going to be just going through section D and section E, and it's going to be talking about inequalities. All right, so this section D, we're going to be referring to linear inequalities, and we're just going to go through the characteristics of them, and just so that way you guys understand what an inequality is and how they differ from an equation. All right, so before we were learning about equations where we were saying x is equal to 5. So x only has the value of 5. That's all it can be. It is simply just 5 and nothing else, because we're saying what x is exactly equal to. Well, when we're dealing with inequalities, we're actually going to have a lot more solutions than just one, because it will then be saying that x is less than 5. All right, and we'll go through these symbols in more detail, as some of you guys were asking me about these questions or these symbols during the map testing, which I wasn't allowed to answer then. But this symbol tells us that things are less than, they're greater than, or they could be less than and equal to, or greater than or equal to, but it's telling us any of the numbers less than 5 occur or are part of our solution. So in this case, if we pick the number 3, 3 is less than 5, so that is a solution. If we pick the number 2, 2 is less than 5, that is a solution. So when it's an equation, we're dealing with just one number typically that is going to be our solution. X is just equal to 5 and nothing else. But when we're dealing with an inequality, we're now going to have a set of solutions where we will have 3, 2, 1, 0, and any negative number will all be less than 5. However, if I were to pick the number 6, 6 is not less than 5, so that one is not a solution. So it's giving us a set of numbers rather than just a particular number. All right, but what you need to be able to accomplish by the end of this video is you need to understand the difference between an inequality and an equation. I just gave a very brief explanation then, but hopefully by the end of the video, you understand what an inequality is, and then you can refer back to what we learned about equations and compare the two. You will also need to be able to rewrite linear inequalities, and then you're going to need to be able to use a number line to show the solutions of your linear inequalities. So unlike where we just say x is equal to 5 and that's our solution, we typically will show more than just this. If we say just x is less than 5, we will usually also draw it out on a graph or a number line in order for us to show our solutions visually, rather than just writing it out as a statement like I have here. All right, so we're just now going to go through all these different symbols and what they actually represent. So these symbols here, we're going to go through all the 4 different types that we have, what they represent, and kind of just go into linear inequalities a little bit more before we start diving into any questions. Right, so an algebraic inequality is a mathematical sentence which compares the values of 2 expressions. It will contain one of these 4 following symbols. So whenever you see one of these symbols, then you know that we're dealing with an inequality and not an equation. All right, so we're going to go through each of these individually now. So whenever we read left to right. So we also read these symbols left to right. And the way that this, one of the ways that I was taught it growing up as a little kid was that these are alligator mounts and that alligators want to eat more and not less. So whichever way that this is opening up is telling us where we have more of. So when we read these left to right, since it's opening up to the left, this one is referred to as greater than. So if I give you an example, x is greater than 5. So that means any number that I pick, 6, 7, 8, 9, 10, and so on, up into positive infinity, any number greater than 5, they are part of our solution. So all of them work. However, if I pick any number that is less than 5, so 4, 3, 2, 1, 0, -1, and so on to negative infinity, none of these work. All right, so we read it left to right, and we're saying that this value is going to be greater than. So x is greater than 5. And then any number that we have that is greater than 5 would actually be a solution to this, because 6 is greater than 5, 7 is greater than 5, and so on. All right, so then we read this next one left to right, and since it's opening up to the right, that means that the numbers on the left-hand side are less than the numbers on the right-hand side, so it's read as less than. All right, so we can go ahead and say that x is less than 10. So that means any number less than 10 is part of our solution. So 9, 8, 7, 6, all the way on to negative infinity, all of these work because they are all less than 10. However, any number that's greater than 10 is not part of our solution. 11, 12, 13, 14, all the way to positive infinity. None of these are less than 10. They are all greater than. So it's not part of this number set. All right, so just to give you an example right now, we would say that 9 is less than 10. So that's how we would write it, and that's how we would read it. All right, but we're going to usually see it with a variable like this here. Now, if you notice, these first two are just the arrows opening up left or right. But then these last two have this line underneath of it. Well, if you think about it, we have an equation. An equation is two lines on top of each other. Well, now it's taking that line on top and turning it into an equality. So this line is just telling us that they are equal to each other as well, or they could be equal to each other. All right, so there's a big difference between this sign here and when it does not have it. All right, so now if we go back to this first one where I said x is greater than 5, if I put the line underneath of it, if I were to say, okay, our number is 5 for this first one, is 5 less than x? No, it's not. So that would actually be part of the numbers that are not satisfying our solution. However, now that it's equal to, equal works. So if I say 5 for x, although 5 is not greater than 5, it is equal to it. So that works. So 6, 7, 8, 9, they are all obviously greater than 5. So they all work and all the way on to positive infinity. All right, but whenever you see the equal to, that also can count as our solution. So here, same thing. If I start doing numbers 4, 3, 2, 1, all the way to negative infinity, none of these are greater than or equal to 5, so none of them work. All right, and then our last one, I'm going to go ahead and write exactly what I had here before. So we can then say x is less than or equal to 10. So that means in this case, if I were to say, well, where would 10 be part of our solution set or not part of it? Well, 10 is not less than 10. It's equal to it. It's not less than. So that's actually part of our non-solution. But over here now, if we put 10, 10 is equal to 10. So it is part of our solution. And so are any numbers that are less than 10. So 9, 8, 7, 6, and so on. So all of these are solutions. And then here, if we start picking any numbers, just like we did before, that are greater than 10, none of those are solutions. All right, so when we're saying less than, equal to, greater than, we're talking about any number that is less than the one provided. X is greater than 5, any number greater than 5. X is less than 10, any number less than 10. X is greater than or equal to 5, any number that's greater than 5, or 5 is actually a solution as well because it's equal to. And then X is less than or equal to 10, same thing. All the numbers less than it are obviously part of the solution, but 10 is as well because of the sign here, because it's equal to. All right, so let's go ahead and go through a couple examples of how we can rewrite them and then how we can solve these as well. All right, so the first thing you must be able to do is when you're given your inequalities, because our next section, when we go to solve for these, just like how we can solve our variable on both sides, left or the right-hand side, we can do that with our inequalities as well. But when we're graphing them, we always want to make sure that we're having our variable on the left-hand side because you can make some mistakes if you don't. So it's just very important for you to be able to rewrite these either way. So when we read this, we're saying 8 is less than x. The alligator mouth is opening up towards x, so that means that x is greater than 8. But we read this left to right. So if we want to rewrite it so our variable's on the left-hand side, well, first off, we write our variable on the left-hand side. We look at our inequality symbol. Well, it is greater than, or x is greater than 8, so that means that the inequality sign has to be opening towards x. And then we will write whatever is on our left-hand side, 8. So this is 8 is less than x, but we can rewrite it as x is greater than 8. All right, so you don't necessarily have to rewrite it like this. However, I anticipate that there would be a lot of mistakes. And the next thing that we're going to do, if you do not know how to rewrite it and make sure your variable's on the left-hand side. All right, so same thing here. This next one, we have 1.5 is greater than or equal to y. So if we want to rewrite this with our variable on the left-hand side, I simply just start with my variable on the left-hand side. I look at my inequality sign. Well, the inequality is opening up towards 1.5, so that means that y is less than it. So we can rewrite it as y is less than or equal to, and then 1.5. So if you notice, when we are rewriting it, our signs do flip when we switch it, when we go from one side to the other. Our signs did flip. However, they did not change with what they were opening up towards. x was greater than 8, the inequality symbol was opening up towards x, so that means it needs to here as well, which it is. Here, the inequality symbol is opening up towards our 1.5 because it's greater than y, and here it's opening up towards it here as well. So even though our signs or inequalities flip, it's okay because we flipped everything with it. All right, so we've already kind of touched on this, so I'm going to go through this very quickly, but solutions to linear inequalities. While linear equations usually only have one solution, and we talked about cases in class before where sometimes there's no solution, and sometimes there's all real numbers are the solution, but typically they'll have one solution. A linear inequality is usually true for many values because we're making statements like x is greater than 1 or x is less than or equal to -8. So we're making statements where we're saying all these sets of numbers that are greater than 1 are part of our solution. So with an equation, there's usually only one value that will satisfy. So in this case, x is equal to 2. Well, the only number that we can use is 2. It's the only solution. However, when we get x is greater than 2, that means any real number greater than 2 works. So there are infinitely many numbers that are greater than 2, so there are infinitely many solutions for this. All right, so that's the difference between the two, that when we're talking about inequalities, we're actually going to be talking about infinitely many numbers, which is why we want to graph them. All right, without being able to graph them, if you wanted to write out or show all of your answers, you would die before you could actually write it out. So by graphing it, you can see the reader or yourself can visually see what all the solutions are rather than just reading a statement like this one here. All right, so let's go through the different ways that your graphs may look, and then we'll do a couple together. All right, so the way that we will show our numbers on the graph is when we get a problem like we have here. So x is greater than 3. We'll have a number line. All right, sometimes you may have to create the number line yourself, but sometimes I'll provide it for you as well, especially on your test I will. All right, but we have a number line. Let's just start it with 0, 1, 2, 3, 4. All right, so here, if we're saying that x is greater than 3, right, the first thing that we do is we can figure out our number 3. So our number 3 is right here. Right, this is where our number 3 is. Well, when we're talking about numbers that are greater than it, are we talking about numbers that are to the left or numbers to the right? So think about this. 2, 1, 0, it's all to the left of our number 3. They're not greater than. 4, 5, 6, all these numbers are greater than. So when we're trying to visually graph our greater than, we will draw our arrow going to the right-hand side. All right, and it's important when it's just greater than, we have an open circle. All right, it's an open circle. You cannot close it. And the reason why is if we have here, our next one, we're saying x is greater than or equal to 1. So let's just do 0, 1, 2, 3, 4. So we know x is greater than or equal to 1. So just like we did here, we know that we can draw a point where our number is 1, and we're going to draw our line going to the right-hand side because all those numbers mean that they're greater than. However, when it includes that number, because it's equal, we close this circle. So it's important that you have a difference between an open circle and a closed circle, because this 3 is not part of the solution because it's open. So it's just greater than. This one is part of our solution, so we color it in. So it lets the reader know that all of these are part of it. This one, see how it's an opening? It means it's not actually part of our solution. All right, the next one here, we have x is less than 8. So I'm just going to say 9, 8, 7, 6, and 5. Well, here when we're going less than 8, same thing, we're going to draw an open circle because it's not equal to, it's just less than. And when we think about this, numbers that are less than 8 are going to be on the left-hand side. So we would draw our arrow going to the left-hand side, letting us know every single number to the left of that is a solution. Right? And then the next one, we have x is less than or equal to 10. So if I do 11, 10, 9, 8, and 7, and then here, since it's equal to, less than or equal to, it's not going to be an open circle like before, but it'll be closed. And then since it's less than, we're going to draw the line going to the left-hand side. All right, so that's the different ways that you can do this. So let's go ahead and just go through 2 examples or maybe 3, and that'll be it for this video. I know this video is really long. All right, we're only going to go through 2 examples. So we'll do A and we'll do D, and that'll be it for this video because I kind of went through, I think, this in maybe too much detail and made the video too long. But here we have A is greater than 1. So the first thing that we do is we see that A is greater than 1, so we're going to find the number 1 on our number line. And then I notice that it's greater than and not equal to, so it's just going to be an open circle. Right? And then when I'm talking about numbers that are greater than, that means it's going to the right-hand side, so that will be our solution, and that is drawing a number line to illustrate the following inequality. So it's giving us all the number solutions for this. All right, this should be a little bit better of a drawing, sorry. All right, then the last one here, we have A is less than or equal to -1. So same thing. I know this is the number I'm talking about, so I'm going to find that number in my number line. And then I'm going to start by drawing a colored in circle because it's equal to. So it's going to be a colored in circle. Less than means we're going to the left because all the numbers to the left of our number -1 on our number line are less than. So then that will be our final solution. All right, that is it for this video.